And these integration tests usually test the interaction with other components or with external systems. So they are slightly harder to maintain, have less of them because usually your unit tests should cover the most of it. And then on top of that pyramid, you have functional tests, which basically test your application from the UI level. So you should have these as well. One specific core principle that I personally find is important, which is not so much technical actually, is the definition of done in continuous delivery. So what means done in continuous delivery? It means you actually got your code into production, and you as a developer, or for you as a developer, that means not just handing over your code to QA, it basically means you will help them to test the code if they need any kind of help defining test cases, or even making sure that the delivery process works or monitoring the app later on in production. So how do you make this happen? How do you put together these steps? In continuous delivery, the idea of a pipeline is brought up, and what that does, it's basically a orchestration engine for single steps that you have in your build process, and it defines a certain order that they need to be executed in. So we'll have a look at one specific build pipeline later on. In between these steps, you want to make sure that you don't move on to the next step if something went wrong. For example, your unit tests failed, or you could say, well, we don't adhere to our coding standards that we set up internally, so you could potentially say, well, I have set up find bugs, and that reported, let's say, 50 failures or problems in your code. So you could say, stop at that point and don't continue until we don't fix that problem. In continuous delivery, they call this quality gates, and we'll also have a look at a couple of examples on what a quality gate is and how to implement it. So let's have a look at an example build pipeline here. What are the specific steps here? So usually when you work on a continuous delivery pipeline, you have to make sure that you have your code in version control. So that's something you have to make sure you have. That could be Git, could be Subversion, CVS, what have you, doesn't really matter. Once you check in your code into version control, in the first step, we would trigger a compilation and unit test task. So that would basically just compile your code and run your basic unit tests. This should happen pretty quickly, so make sure this happens like within 5 to 10 minutes. And when I say this should happen quickly, you want to have fast feedback. You want to know if something's broken early on. In the next step, you could run integration tests, and you might ask yourself, well, couldn't I run them together with unit tests? Again, you want to have a fast feedback cycle. That's why you keep them separate. They usually tend to run longer than the unit tests. You could integrate code analysis tools. I already talked about enforcing coding standards or finding potential bugs with find bugs. And then at some point of time you could say, well, we're ready to package our application and deploy it to some environment. Deploying to the environment test would happen first. So test could be some sort of like integration test environment where you run your automated functional tests against. One important thing about building your deliverable is that you actually just want to build it once, and then you want to reuse it. So you don't want to like necessarily introduce problems or side effects if you rebuild it multiple times just for specific environments. So later on, we'll actually have a look at what to do with this deliverable once you build it. So here you can see we can later on deploy it to UAT or test production environments. That's how a basic build pipeline looks like. I'll show you later on how to build one. So potentially you read the book Continuous Delivery, which came out in 2010 or so. It gives you all these ideas about continuous delivery, but you might ask yourself, well, how do I actually implement that? How does that look like technically? Do I have to use a build tool? Does this have to be Gradle just because we're at a Gradle conference? Could this be Maven? How do I tie together each of these steps that you want to run? Do I have to use a continuous integration server? Does it have to be Jenkins? No, it does not have to be Jenkins. What I'm going to show here is a combination of Gradle and Jenkins, but you could potentially use any kind of build tool plus any kind of continuous integration server to do this. So before we actually look at building this pipeline, let's first have a look at the sample application that we're going to bring through that pipeline. It's very revolutionary. It's a to-do application. So you can basically create new to-do items on your list. You can say, I'm done with them. You delete them, or you can filter them based on active or completed. Based on the architecture, that looks actually fairly simple. So it runs on some sort of web container, so it's a Java-based web application. You could use Tomcat, which we'll use actually later on. We have some sort of data store. In our case, that's a database, which we read and write the to-do items from. And you can access that application over the browser, so fairly simple. So when we look at the actual structure of that project, it defines 3 different modules, so to say, 3 different components. In Gradle, you would say, well, we have a multi-project build. These are all projects. So we have a model which defines the data classes for the to-do items. Fairly simple. We have one that defines a repository component, which gives you the data access layer for getting this information and translates into objects. And then we have a web component which handles the HTTP requests and in the end renders the to-do items in the browser. We see certain dependencies here between these components. So this can be modeled pretty easily in Gradle with multi-project builds. So maybe you should check out one of the more introductory talks. I'm not going to talk about how to set up a multi-project build. So let's have a look at the project hierarchy of our sample project. So you see on top there's a to-do root directory, and then we find our subcomponents here as well, model, repository, and web. And underneath each of them, you have a project-specific build.gradle file. It defines specific tasks or configuration for a specific project or component. So in the web project, we could say apply the WAR file, WAR plugin, or tell me how to bundle the WAR file, that kind of stuff, which is totally not relevant to model or repository. Then on the top level, we have a build.gradle file and a settings file. In the settings file, you define which of the projects should take part in the build. There you see all of them are part of the build, model, repository, web. And then on the top level, we have some additional files, which are the Gradle wrapper files. I guess most of you guys know what the Gradle wrapper is. If not, it's a bunch of files plus a micro library that you check in with your version control system with your project. And what happens if you run one of these shell or command line scripts, it will automatically download Gradle with a specific version that you defined in your project and make sure that you have a reliable build. So you don't actually have to tell every developer on your team, install Gradle with version 1.5 or what have you. You simply define a wrapper, and I highly recommend using the wrapper. You can also run it later on the continuous integration server. So there's actually no setup needed, which is great. Then I usually like to organize specific functionality under a subdirectory named Gradle. So there could be multiple files that sit there. I'm just showing one here. But I usually like to put fairly complex logic into script plugins and organize them here in this directory, just to give you an idea of what you can store there. So one of these examples could be, well, we want to define the versioning strategy for our project. So our artifact should be named a specific kind of way. Or we want to set up integration or functional tests, or we define how to deploy our artifact. Let's have a look at our artifacts that are produced by our project. Yep.
Just one question. On the previous slide, why wouldn't you use build source if you're in a multi-project build? Why wouldn't you just use the
You could do that too. I mean, it's just one option. So we have multiple artifacts that are produced by our build. So the model project creates a Java file and the repository as well. They both apply the Java plugin, so nothing special there. And then the web plugin puts it all together. It includes both Java files, and that's the one we actually going to deploy to a Tomcat server. So let's have a more fine-grained view on how the build pipeline looks like, and that's kind of defined by what the continuous delivery book says. In the continuous delivery book, the author talks about specific stages, and the first stage that you would handle is the commit stage. At that commit stage, you would make sure that your system works on a technical level. So you compile your code, you run your unit and integration tests, you can run some code analysis tools, and at some point of time, you assemble your distribution and then publish it to a binary artifact, or at the moment, I would say central location. We will use a binary repository later on. After you're done with the commit stage, you will move on to the acceptance stage, and that stage basically retrieves these binaries, whatever it is. In our case, that's a WAR file, from the binary repository and deploys it to some sort of environment. And in this stage, it's usually some sort of integration environment. And how I told you before, we run the functional tests on top of them to make sure that they work on a UI kind of level also. So we can take off the burden a little bit from our QA team. We have some automated tests which tell them, well, the core use cases work. And then at some point of time, you say, well, the QA team is ready to test our code, our application. There are two more environments that we want to deploy to. So there's a UAT environment and a production environment. And of course, we want to deploy the artifacts there as well. In this case, our WAR file. What's kind of different from the other phases is that you want to trigger this manually. So what you want to implement is some sort of like push button release functionality, where you let, for example, the QA team decide when they want to put in a new artifact or a new version and start to test it. Or you could even tell your product team, when do you want to get some new feature into production? So you can just give them a button and they click on it and they say, well, we know this artifact with this version includes that feature, deploy it to production, give it to the end user. So let's have a look at the first stage in continuous delivery, or in the pipeline. And that's actually fairly simple to implement with Gradle. I don't think I actually have to talk too much about it. We compile our code, we run our unit tests. Because we are working with a Java-based application, all you need to do is to apply the Java plugin. It already gives you the tasks to run unit tests to compile your code. If you stick to the conventions, really, there's not much to configure. You can mix a whole bunch of unit test frameworks if you want to. I personally prefer Spark, but that's my personal preference. You could even like mix multiple frameworks within one project. It's all configurable in your Gradle build. I already mentioned, make sure that at this stage you get fast feedback. So optimally, it should be less than 5 minutes, but 10 are probably okay. It runs with every check-in into version control. And your priority as a team should be, whenever that build is broken, you should actually fix it, because you prevent yourself from delivering software. Then you can move on to integration tests. So they're usually longer running tests. They might require some sort of environment setup. For example, you might have specific integration tests which test a database access layer, which calls the database, and you want to test that specifically. They're harder to maintain, and you might actually have problems in case that specific environment is down, so these tests would fail, so they're kind of like harder to maintain. So how do you do that in Gradle? Well, if you stick to the standard Java conventions, you could simply say, hey, I'll just put them in source test Java, why not? And I give it a specific naming pattern. So for example, all my integration tests would be named blah, 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 itest.java, or integration.test.java. The problem with that is that if you mix up these types of tests, you actually have to communicate that to your developers as well, and they actually have to make sure that you don't mix them up, otherwise you run integration tests in your earlier phase, which you want to avoid. What I personally like to do is to separate them into a different directory, and here I call this directory source integ test Java. I believe that's something that the Gradle core base uses as well, but you can name it whatever you want to. It doesn't really matter. So all your integration Java source files would sit in that directory. How do you make this happen in Gradle? The Java plugin introduces the concept of a source set. And if you apply that plugin, not only do you have the standard source sets, source main Java and source test Java, you can also add new ones. And here you see we add a new one here named integration test. And then we can say, well, the Java sources sit in source integ test Java, or property files or whatever resource files you have. They sit in source integ test resources. We can define a specific compile and runtime class path. Very specific to integration tests. They might not be different from your regular unit tests, but you can do that. And you have a specific task, a separate task of type test, which is one of the API classes that Gradle provides you to define a new task which lets you run integration tests separately. And there you see here I reused the source set. So we say, well, the test classes directory is the one that the source set defines, and it's the output classes directory of that source set. What I personally like to do as well is separate the test files. So whatever test results files come out of there, usually XML files or HTML files, I keep it in a separate directory. Here it's called integration. Later on, if you need to, you can actually merge them. That's no problem. To run it, simply use the Gradle wrapper and say, run the integration test task. So I already talked about a typical use case for integration tests, and I know it is like a very a topic that people ask a lot about on the Gradle forum. They, for example, say, well, if I want to run my database integration tests, I don't want to rely on a specific database in some sort of environment. I actually want to bring up my own embedded database. And to make this happen, you would actually have to extend the regular build lifecycle that Gradle gives you with a Java plugin, where you say, well, I want to start up my database first. Then I want to build a specific schema that resembles the one that I have in production. And I might potentially also want to have some sort of seed data that I can rely on. Then after I do that, I want to run my integration tests. And later on, once I'm done with that, I just want to stop it. There are certain tools that you can use to implement that. I haven't used any of them, but I know some people do use them. So they're called Liquibase or Flyway. They let you define your data or the XML schema, the schema in XML of your database, and they help you just to set up specific tasks here. What I did not use these things. I simply set up a H2 database, and I extracted all this code into a Gradle file here, which sits under Gradle, under my project directory, and it's called database setup. That's a fairly simple script plugin. It defines these tasks that I talked about before, so it allows you to bring up the H2 database, add some data to that database, and then later on start the integration test as well. And there you see you can use simple task dependencies just to wire this in, hook it into like the verification check task, and all you need to do is simply use dependencies. So when we talk about unit integration tests, usually what is mentioned in this kind of context is code coverage. And I think code coverage is important. It doesn't necessarily tell you anything about your code quality. It says, it simply makes a determination whether certain pieces of your code are exercised. So aiming for 100% test coverage doesn't necessarily mean you don't have any bugs in your code. It really depends on the assertions you make and what you test in your tool. So when we talk about code coverage, you will have to pick some sort of tool that you want to implement this code coverage with, that you can generate all this data. So you might know some of the more popular ones, Covertura or Emma. These are the older ones. There's a commercial tool called Clover. that you can use. And when we talk about, well, which one should I pick, I think we should actually look at how they work internally. How do they generate code coverage metrics? And when we talk about that, there are various ways you can generate these. So let's have a look at how each of these tools work internally. So Corpatura, what it does, it modifies your compiled bytecode and inserts instructions to later on track what kind of code was executed. Something really you actually don't want to do in continuous delivery. You don't want to change your compiled class files. You don't want to have any kind of side effects. Same thing is done by Emma. Clover does it slightly differently. That tool actually changes the source code before you even compile it. So it almost sounds worse. So what some tools do, they copy the original source code to some other place, and then later on use the other copy to run your code coverage tools to instrument your source code, and then copy it back into your original location just to build the WAR file and compile it. But it's not optimal. There's a better way of doing this, and this is implemented by JaCoCo. It's a code coverage tool, but instead of changing the source or bytecode, it actually adds or hooks up a JVM agent at runtime. So whenever you execute your unit or integration test tasks, it automatically hooks in and doesn't change anything, which is great. So just to wrap this up, JaCoCo, it's called on-the-fly bytecode instrumentation, and it doesn't change anything. So that's my preferred solution of generating code coverage. So how do you implement that in Gradle? Here you see just some script plugin. It applies the JaCoCo plugin. And here still, you can see it's a community plugin. It's been pulled from Maven Central, and it was implemented by one of the more better known people in the community, Andrew Oberstar. The plugin works really great. All you need to do is to apply the plugin later on. And here we have some specific configuration on top of it, which tells the plugin also hook into the integration test task to generate code coverage. So we're not just generating code coverage for unit tests, but also for integration tests. With Gradle 1.6, the plugin is included. So maybe if you're already using that, you can hop onto that train, try that one out. Still in incubating status, so there might still be some bugs. But I can tell you it works pretty well already. So how does JaCoCo generate the reports? So usually in the first step, whenever you run your test tasks, in this case for us it's test, which comes from the Java plugin, and the integration test task, which we defined, it automatically hooks into it, and after they ran, it creates so-called exec files. So just binary files which contain the coverage metrics. Doesn't really help you as a user. Well, you want to see some sort of HTML file. And the plugin, or the JaCoCo plugin, lets you translate these exec files into actual HTML files. And there's always a corresponding task provided by the plugin based on the name of the test that you have in your project. So in case for the regular test task, it's called JaCoCo test report. And then later on, if you open these HTML files, you can see line branch coverage, that kind of stuff. If you're familiar with code coverage, that shouldn't be too surprising here. So code coverage is only one metric that you can run in the code base. There are many more tools that you can run. I already mentioned some of them. What you want to determine is what is the health status of my project. Do I have any kind of potential security defects? Do I have coding standards problems? Or simply just developer bugs, which are easily discovered by some of the tools. For example, find bugs lets you determine certain typical errors you might make.
Is there a reason you recommend running that after all of the testing?
No, you can order it how you want to. So it's not recommended. The continuous delivery book does that. But you could also run it separately if you wanted to. If you say it takes too long for your build, for your project, you could run it as a separate task alongside your build pipeline if you want to. I already talked about quality gates, and in this case, one of the quality gates could be, well, our code coverage is only like 20%, but we're aiming for 30%, whatever it is, then you would actually fail the build here. And that's something you can build in automatically. Well, all these tools give you some metrics. Yes?
What I found is the code coverage for Gradle, none of them have the build fail on it. Like at code return and add, the build will fail if my code coverage isn't at least 80% or whatever I set. I mean, so is that just in there for reporting purposes, or should you look at the output and fail it?
I mean, whether you want to fail it or not, that's pretty much up to you. Some of the static code analysis plugins that Gradle provides you give you actually the configuration options, whether you want to fail your build or not. So that's really up to you. For code coverage tools, well, it should be configurable, and we'll have a look at it later in the Jenkins build, actually, where we configure this quality gate. So you want to record progress over time, where you say, I don't want to compare HTML files individually. Don't want to have a look at a file that was generated like 2 weeks ago and have a look at the one that I just built. What you want to actually do is record progress over time to see whether it improved or not. So I already mentioned a couple of these tools, PMD, find bugs, CodeNarc, check style, JDepend. It's actually fairly easy to configure them for your build. All you need to do is to apply the corresponding plugin. You have to give it some rules that you can put in any kind of directory in your project, and then you can say, well, which of the reports do I want to generate? And then all you need to do is run the check task. They're automatically hooked up, and they will run in your build. So I already talked about tracking code quality over time. And well, these tools really don't provide that. There's a better solution, I think, and it's called Sonar. Sonar is an open source project which allows you to gather metrics over time and stores them in a Sonar database. It comes with a web dashboard, so you can have a look at them over time. They will actually change. And it brings them all together. So it's not just like one specific HTML file for one specific tool. No, you can define a so-called quality profile on that server, which lets you define the tools you want to use and also the rules you want to apply. So how does that work in Gradle? Gradle provides a plugin called the Sonar Runner plugin. It's easily applied to your project. It doesn't need a lot of configuration. You might have to change the configuration for the database that you want to point to, but when you run it, it will analyze your whole project and push the metrics that it generated into the Sonar database. All you need to do to configure it, and that's basically on the root level of the project, is to apply the Sonar Runner plugin. And here you see there are some Sonar properties that we set. So we can set the project name. Usually that's derived from your actual Gradle project name. But just to show you that you can change certain properties, you can do that here. And you can say for all subprojects, I want to set specific properties as well. Yes?
Quick research. Don't you have to tell where your Sonar server is?
You can put it anywhere on your network.
You can figure that here.
Oh, you can configure it here. I didn't show it. This is using the default settings,
Okay.
which uses a local host and some port, I think. Yep.
Last I saw, Sonar only kept the last set of records for the day. Has that changed?
It gives you a trend, so you can see how it changes over time.
Even within one day?
Yeah, it should, even within one day.
That's not what I've seen.
I think you need to give it a named version, so for that day, you have to give it an individual version. Or there's something else or something, a timestamp.
Yep. I mean, it actually changes based on the version, and we'll talk about changing the version for a specific build dynamically later on. So once we push a new version, it will change, show the difference. So let's have a look at how this actually plays out in practice. So here you see the Sonar dashboard. Currently there's no project configured. And then we're logged in as administrator, so we can configure everything here. Then we go to our project, run the Sonar Runner task. Does a bunch of things, and here you see I actually do have something in build source. And then at some point of time we see, here you go, it runs a bunch of tools on your code base. And when we scroll through them, you can see there's find bugs and all kinds of other stuff that we use here, checkstyle, I believe, PMD. Yeah.
If I already use find bugs and have a find bugs run and a Cobertura run, is Sonar gonna redo those?
Yes.
So it'll run it twice, effectively?
Sonar Runner runs independently from the applied code quality plugins in your Gradle project.
I think you can import reports from previous runs into Sonar.
Okay. I only know about unit test reports, for example, coverage reports. I'm not so sure about static code analysis reports. That's basically how they use it. So when we now go to the dashboard again, you can see it reads from the Sonar dashboard, and you see all these metrics in here. So there you see there's like some sort of like method complexity that you can drill into. You have all these nice statistics up there. Up there is some violations from find bugs. You can go in as well, so you can actually drill into each class, and it shows you, here you go, well, apparently it tells me hopefully you close your JDBC connection, that kind of stuff. And here you actually see we also imported the JaCoCo code coverage reports, so you don't have to redo them. It actually, the JaCoCo plugin internally configures that it should be pushed up as well. We talked about the code coverage for integration tests as well. You can configure a specific widget for it. So you just have to go to that dashboard and like add it here. And there you see you can drag it down, organize it how you want to. And there you see I have a code coverage of 27%. So we're actually better in integration tests than in unit tests. And if you drill in, you see some class again. Everything marked in red is not covered. Just one of these classes is, one of these methods is actually covered. So we certainly have to do a better job here. But that's pretty much Sonar, yes?
So does the plugin do the incremental analysis? Or?
That's what Sonar does. So once you push it up, it will automatically determine it there.
So if you run it...
So it will compare it to previous metrics that get pushed up.
But what I was saying is if I have 25,000 tests, and I run this again, and only 100 have changed, is it going to run analysis on this 100, or it's going to run?
No, it's going to run it on both. So we ran some code analysis tools, and we're compiled our code, ran unit integration tests. Now we're actually ready to assemble our deliverable. In our case, that's the WAR file. What I personally recommend here is don't include environment-specific configuration into your WAR file. There are some tools that you can use to sync it automatically with your environment, like Puppet and Chef. So certainly have a look at that one. Personally, I like to include build information. So you can include a file which makes a determination about, for example, what OS did we run it on, who ran it, when was it run, what's the version number, that kind of stuff, and you can actually read that as maybe potentially as some sort of administrator within your build, within your running application, sorry. Which brings us basically to a versioning strategy as well. So you will have to give your artifact some sort of version when you build it. So if you're coming from Maven, you're probably used to adding the -snapshot suffix. So for a while you would work on some feature, still snapshot, you potentially push it up to binary repositories, And at some point of time we say, well, now we're ready. We're ready to release this artifact with this version. Then you have to change the POM file, change it to 1.0, check it into version control again. So you have to do all this work just to make sure that you change it to a really final version. Well, you can use that with Maven fairly easily. So there's the Maven release plugin. I believe there's a Gradle release plugin as well, which I personally haven't used. Well, how does this play out in continuous delivery? Well, given the fact that, I talked about this before, that every commit can be a potential release, there's not really the concept of a snapshot anymore, where you say, well, I work on it for a while and then I release it. Well, you can have different branches, but once you commit something to whatever branch you use, you can already set the version number that you want to have in production as well, and that version number can be built dynamically. So you could define the project version, minor and major version in your project, in your Gradle project, and then later on you can use some sort of other dynamic version number, and we will use one from Jenkins. It's automatically provided as a system environment variable to build this whole version of your artifact. So how do you actually implement that in Gradle? So I, again, use the script plugin. You can put it under build source as well. Doesn't really matter. It's actually it's better to put it under build source because it'll automatically compile. And then we can say, apply this to all projects of our build, which basically says we can access the version information in any sub-project of our build as well as the root project, which is fairly convenient. So how do you implement that? So this just shows the content of versioning.gradle. So you can basically, because we're in Groovy as well, we can simply define a class here called project version, and it defines 3 different fields, major, minor, and build, and it corresponds with the ones I showed you before. You can set the specific values in the constructor, and the to-do method would basically create a string representation of that version. In the end, once you instantiate this class and give it a specific values, you can actually assign it to the version property of project. So it would be available to your project. Up there you see another property that I defined. It's called build timestamp, and it just determines when you build your artifact, which can be kind of handy. And there you see we will use a system environment variable called source build number, and we'll later on provide that from Jenkins. So I already talked about that we wanted to include some sort of build information. Now that we have a versioning strategy for our build, we can actually include this information. So we can define a new task here for our web module or web project called create build info file, which basically just creates a properties file, which sets 2 different properties here. And the version here in this property file is the version number that we dynamically created through our versioning strategy, and it will be assigned as a string. We can also see that build timestamp here, so it's assigned to that one. So we just store it somewhere in our project in some build directory. Then later on, we can say when we package it, and that's actually fairly readable, even if you didn't use the more plugin before, we can simply say from the build directory, include the file build.info.properties and put it into the directory web.inf classes. So later on, you can actually read that from your application if you want to do that. All you need to do to put it together is called the assemble task or the war task. It's up to you. So now we have the artifact there. We're ready to push it to some central location. I already mentioned before, in our case, we want to use a binary repository. So we have a versioned artifact, and you can use any kind of like binary repository that you like to use. So you could use Sonar type, Nexus, or Artifactory. In our case, we will use Artifactory. I will show you how to push that up there. Once you push it, you don't want to push it again. Well, this information is already there. You have the artifact. And later on, you can actually reuse that artifact to deploy it to different environments. So all you need to know is basically the group ID, the name, and the version. How does this look like? From Gradle, we push up a artifact with the version number, for example, 1.0.34. And you can see there are already some other artifacts up there with different versions. And here you see Artifactory, we use that one. So how do you, in your build, configure where this Artifactory server lives? So you have to give it some properties which defines, I want to push it up there, and it requires these credentials, or we want to push to this repository specifically. What I personally like to do is to use this kind of actually the same method that Grails does. So Grails uses a Groovy file to set certain properties for your project. They can either be common configuration or they can be environment-specific configuration. So what you can basically leverage the same kind of functionality that Grails does. And how do you do that? Well, the Groovy API provides the class named config_sloper, which is used by Grails as well, I believe. And here you see up there we have one configuration block that defines the binary repository. So it's very expressive. You can give it a URL, username, password, and the name of the repository. For later, we can also see there are some environment-specific settings here, and these define the servers that we want to deploy to. So these could be different. And of course, later on, make sure that you don't store credentials in there. You can actually extract them into other files, potentially Gradle.properties files or D file. You don't actually want to store any kind of like credentials in your version control system. So how do you make sure that this configuration file gets read before you execute any of your tasks? Well, you can write a task which is executed in the configuration phase. So even before any of your tasks execute, we can use the config_sloper here, and the config_sloper uses a provided project property called env. If nothing is set, it will simply assume the test environment. We just log it here, and then later on, we use the config_sloper to parse that file, which sits in Gradle config build config.groovy. And then we can say, well, assign this configuration to a specific extra property to all projects of our build, which is kind of nice, because now we can use the config property to read any kind of like configuration value that we defined before. So at runtime, or even before you run it, you can determine the environment that you want to run something against on the command line. So you would simply say Gradle w-p env, and then the specific environment that you defined. So how do you actually push it up? I think in the newer version of Gradle, there's the new Maven Publishing plugin. I think they started with 1.3 to introduce it. So all you need to do is to apply the plugin Maven Publish, and there you can actually see we built the full URL of our binary repository based on the configuration that we read. So there you can see we use config.binaryrepository.name and the base URL as well to put it together. For your project, we just have one artifact that we want to publish, and that's the software component of our project. And that's going to be a Maven publication, so we want to publish to a Maven repository. Well, you can give it a specific name. I used web app here. You can name it whatever you want to. And then we can, down there, also say, what's the repository that we want to deploy this to? And then later on, just say Maven, Gradle w publish. And we'll build the artifact and publish it to that repository. So let's see how this works in practice. So there you see we have Artifactory, and this is one of the default repositories that we want to deploy to. So all we need to do to emulate this kind of behavior of building that version number, so we can export that system environment variable that we defined before, and we call it 33 in this case. And then we say build our artifact and publish it to Artifactory. So what we expect to happen is that we create a WAR file with a specific version 1.0.33, which happened here. And then we push it up to that binary repository that we configured. or that we read from our configuration. And you can see, you can go back to the repository, you refresh it, and you see the group ID that we defined, and the artifact name, including the version. And you can see there's a POM file and the WAR file. We didn't even like customize our POM file for now, just to show you that it actually works for a different number as well. We just set 34 here, and we publish it again. And what should happen is that you will see another artifactory with a different version number. So perfect. So now we're ready to actually almost deploy it. And to deploy it, well, we have to retrieve it from the binary repository again. Well, you could also store it somewhere in Jenkins or some server that you want to define. I mean, that's up to you. I personally like to prefer a binary repository. It's a better place to store things. You know exactly which versions are there. You can potentially use them to roll back a like production version, for example, so you can always fall back. You have all the meta information, when was it built, and so on. So to do this, you actually have to request a specific versioned artifact. What I personally like to do, I create a task which simply downloads it from Artifactory. They expose a API, which you just have to put together. So it's a RESTful URL that you put together. You already know the version number. And you retrieve that artifact and store it in some sort of temporary location in your project. So you can say, well, we want to deploy version 1.034 of our WAR file. So we get it from Artifactory, and then we can deploy it to various environments. You just have to actually get it once. And then in our case here, this will be a Tomcat server, and we'll trigger that based on our env property that we provide on the command line. How do you download that artifact? I personally create a custom task. So there's some logic which actually retrieves it over HTTP, which you don't see here. I don't want to talk about this too much. But basically what you do, you define the target artifact name and the source URL that you want to pull it from. And all you need to set then in your custom tasks are two different properties. So one of them is source URL. That's the URL of your binary repository for that specific version artifact. And then you say the target binary should live or should be downloaded to the property that we set up there. All you need to do then, you just run the task. It will be automatically downloaded to you. And then we're basically ready to deploy the binary. I already talked about deployment on request before. So for some environment, you actually only want to deploy some sort of stakeholder wants you to deploy it, or they want to deploy it. If you deploy some sort of code, make sure whatever method you use to deploy that code, it's being used for all environments that you use. So it should be the same code that you exercise for production, the same one as test, because you don't want to find out later on, once you're ready to deploy to production, that your code for production doesn't actually work. So it should be the same kind of code. You should change it based on certain properties that you had. And make it reliable, because you will have to deploy many, many times. Well, I already mentioned that you can deploy to multiple environments now. You have all the configuration in your Groovy file, and then you just have to provide the specific environment that you want to deploy to, again, with the command line parameter. Well, there are certain methods you can use to deploy artifacts for web applications. Some people use custom built scripts, like some shell scripts, which basically shut down your remote server, delete the old artifacts, copy the new one over, bring it back up again, just to make sure that everything is clean. Just to show you that you can also do it in Groovy itself, I just picked one of the plugins that you can use that's based on Cargo. And Cargo lets you deploy code to a wide range of web containers. You just have to configure which one it should use. And here you can see Well, there's actually a DSL for using Cargo, and that's provided by an external plugin called the Cargo plugin. So you can see, well, we have a configuration block called Cargo here. It provides a container ID, so Tomcat 7 should be used. There's a port, and the port is read from our Groovy configuration that we read before. There's another configuration block here which defines the actual deployable. There could be multiple deployables as well. And we can say, well, it lives on that host name, and we require to have these username and password. So what needs to happen beforehand is that we actually download the binary from the repository. And here you can see we just define a task dependency to do so. So that makes always sure that you actually have that artifact beforehand. You can say, I want to undeploy my existing artifact beforehand. So there's another task you can use, Cargo undeploy remote. And that one says, only if the context is accessible on that server, only then undeploy it. So that actually would be skipped if it doesn't already exist yet. I don't actually show you the closure here that defines that logic in app context status, but just assume it happens. And then all you need to do, you provide, again, a specific environment that you want to deploy to, and then simply say, run the task Cargo deploy. So let's have a look at one example here. So here we see it's like one of our servers. It runs on port 8099. It's a Tomcat 7. And we can go to the manager app to see whether there's already an existing application. No, there is not. So now we're going to make first sure that our artifact doesn't exist yet. And that will be stored in web build download. So we just have a look at the directory tree here. It's not there yet, but what should happen now when we run this, it should automatically get the artifact beforehand. So here you see we run against the test environment. There's a nice log statement here. The next task tells you, well, there was nothing to undeploy yet, so we'll skip it. And then we download the binary, and we can check it now. Well, here it is. It's the artifact 34. And then we deploy to the remote server. And then if you go back to the manager console, you can reload that. And here you go. You have the to-do application. And then if you open it up, unfortunately you can't see it here, but there's like the actual build information that I print out here. So it shows the version number and the build timestamp. It's a little bit gray on gray here. And then you can actually start to use it and run your functional tests on top of it. Which brings us to functional tests. So what you want to make sure here is that you test certain permutations based on your UI. So if you have a web application, you might want to run against Chrome and Firefox, potentially against Safari. You want to test the most important use cases. So for example, if you have some web application, common use cases are the sign up or login, that kind of stuff. And you want to potentially run them against different environments. So you can not only use them to test to run them against your test environment, you can also use them as smoke tests against production, for example. So once you deploy to production, you can say, well, I'll just run it again to make sure the basic stuff works. So how do you develop these kinds of functional tests locally? So what you would need to do is to have some sort of running container. And again, we have this typical setup where you need to have some sort of environment beforehand before you can actually run some sort of tests. Here I'm actually using the Jetty plugin, and I defined two tasks here of type Jetty run and Jetty stop. They make sure it's being brought up or shut down later on. You can give it some sort of properties here, like the port, the stop key, and the context it should run on. And we say we run it as daemon. So it runs in the background. And just to make this happen, you create a new task called functional test. It's again of type test. And you can basically hook it up here into your build lifecycle. Oops. So here you just define basic task dependencies. I know that in later Gradle versions there should be a more elegant way to configure that, but they're not there yet. So when you want to run specific, so that's very helpful if you want to run them locally on your machine because you have to develop them at some point of time. If you want to run them against your remote machine, you can have a new task, and I called it just remote functional test. And in our case here, I'm actually using JEP. You don't have to use that, but it's kind of handy because it provides some properties here that lets you define which browser you want to run against. So here we can see Firefox. And down here we can say, run it against this URL specifically. So you can actually target multiple environments as well. It's actually not too much magic. If you have a look at the code example provided with the slides, you can actually run one of these examples, which shows you how to set up a functional test with JEP in your build. All you need to do is run this task and define the specific environment. If you wanted to go further, sure, there are smoke tests, there are load tests, or also called performance or capacity testing. I won't go too much into detail, but there's a pretty nice plugin for JMeter that you can use. It allows you to define a specific test plan, and you can say, well, hit these URLs in this random order potentially, and then print out the actual results. And later on, you can actually integrate that as well into Jenkins, into some sort of job. But I won't talk too much about it. Have a look at the code example. So now we're actually ready with the Gradle part of our build. So we have each step along the way, and we can basically now bring in Jenkins to put them together. And in this case, Jenkins takes on the role of the build pipeline and the orchestration engine. So all you need to do is set up Jenkins jobs, and there would be one initial job that pulls your source code from version control. If it determines some sort of change, it would trigger specific builds each step along the way, and would basically implement whatever we talked about before. Well, currently there's no one plugin that you can use to build a build pipeline with Jenkins. So you have to piecemeal it together, which is not so awesome, but I mean it works, and it will show you how to do it. Your initial start would be to create a Jenkins job for each of the tasks that we discussed before, and then you can later on chain them together to define dependencies. There will be one task which would be the initial step, which will be compiling our code, running the unit tests, and that one is called here to do initial. It could have been called something else, but that's pretty much the one that checks your version control system, whether there was a change, and make sure that you run a specific build in your build pipeline. So let's have a look at the initial build job. Here's that Jenkins build. If you used Jenkins before, there's really not so much special about it. Just to point out some interesting things here. There you can see there's a specific name that I give here. It's called to-do pound, and then the current build number of that build pipeline run. And that number is actually provided by Jenkins. So if you run a Jenkins job, it will give you a specific environment variable that you can use to build up this name. And to build up this name, you can use the so-called build name setter plugin. You can give it any kind of string and put together dynamic values, and will show up here in your dashboard as well, which is kind of nice, particularly if you have multiple build pipelines. As you can clearly identify which one you're running here, which one are you looking at. For a quick look at your code coverage, there's the JaCoCo plugin, so you can simply read the exec files that we talked about before, and will then show up here in this dashboard. And then you can use the so-called parameterized trigger plugin to define which downstream project should be called if this one is stable that you're currently working on. So in our case, we want to call the integration test job if compilation and unit testing worked. How do you run the Gradle builds? There's a Gradle plugin, of course, developed by one community member as well. It allows you to set the Gradle wrapper, so I totally recommend using that. Don't install some sort of other version on your integration, continuous integration server. Simply build on top of the Gradle wrapper. And then for the initial step, we can say clean out the workspace first, because we don't want to reuse any kind of artifacts that are still hanging around from previous builds. And then run the test task, which will automatically also do compilation. Just to show you how you can put together this build name. So it's the build name setter plugin, and it will show up here. And all you need to do is this expression down there. So once you install this plugin, you can define some sort of what do they call it here? Build name. It's actually some sort of expression. It makes sense to have a dynamic build number here, and the build number is provided by Jenkins. It's a system environment variable that you can use out of the box. Just a couple of words about the parameterized trigger plugin. Well, it lets you define the next job in line once you're done with that one. So you can say whenever my build is stable, call the next one, and in this case it's to do intake test. And then we can also, and that's why it's called parameterized trigger build plugin, we can hand over some additional parameters that you can define here. And we call this one source build number. And that basically is assigned the initial Jenkins build number variable. And you might remember we use that source build number in our Gradle build because it's available as an environment variable to build up our version number. One thing I found helpful is the clone workspace SCM plugin. So in your first job, you want to pull everything from version control that you have, any kind of changes. But then later on, you actually don't want to pull them again because there might be some other change that happened. So what this plugin does, it allows you to wrap up, basically archive the existing workspace of the initial job and provide it to later jobs in that build pipeline. So it would basically tar up your existing workspace that you pulled from GitHub, and then it would be provided to the next job in line, which is kind of great. And it simply you can basically reuse compiled classes if they were there, so you can they basically are up to date if you run your build again. So there's a lot of benefit to that. A couple of words about the JaCoCo plugin, and up there it's just the general JUnit configuration, so you can define, well, show me the unit test as well. There's actually nothing special here. This actually doesn't belong to the JaCoCo plugin. It's a default functionality of Jenkins, and down here we can say, once I install the JaCoCo plugin, we can now point it to specific exec files and implement these quality gates that I talked about before, where we can say, well, if the line coverage is only 69% and not 70, then the build will actually fail and will not continue in that build pipeline. So this is the view of the next job in line, where you can see we can use these two plugins again to clone the workspace that was initially tarred up from to do initial. And we use the most recent completed build. And down there, we will also want to set the build name for that job. Here it looks slightly different. That's a very specific thing to that plugin. We have to say to do pound and then say use the environment variable called source build number. Well, have a look at the documentation. It's very something specific to that plugin. I talked about manually triggering builds. And that's specifically true for deployment tasks. So here you see a deployment task for the UAT environment. It calls our cargo deploy remote task. And then later on, we can use the build pipeline plugin. It gives you the option to manually define that the next job in line should be only executed manually. So it doesn't automatically run. It only runs if you actually click a button. And where do you click that button? Well, it also comes with a nice visualization of your whole build pipeline. So once you chain all these jobs together, that plugin automatically provides you with a view that you can configure for your Jenkins server. And here you see there's like one row for each of the builds that you ran in your build pipeline. On top you see it's also color-coded. So the one green was successful, the one in yellow is currently running, and the blue ones are still supposed to run. Let's see, here's one of these buttons which allows you to manually trigger a build, deployment. So you can see here for to do deploy UAT, you can press this button later on. Actually, this build pipeline doesn't move further. It stops here, and only if you press this button, it will actually deploy it. So I have a little demo here still, just to give you an impression in practice. So here's the whole set of Jenkins jobs. This is provided by the JaCoCo plugin, just some nice overview, kind of like code coverage. And then we configured a view for our build pipeline called to-do application. And you see multiple runs here, everything green, so it looks fairly good for us. And this is the button actually that's being used if you want to manually trigger, for example, performance tests or deploying it to UAT, for example, or production. To run it, I think we just pressed the button. So it triggered, no, never mind. We'll have a look at the configuration first of the some of the build jobs, just to see how it's configured. There you see the downstream project is the next one in line, integration tests. So if you look at the configuration, here you see we pull from GitHub, so it's just a plain repository. We say pull every minute to see if there were any kind of changes. We set the build number here, and then later on we use the Gradle plugin to run the clean and test task, and the Gradle wrapper, of course. And then later on we will package up this workspace that was pulled down from GitHub. And then we say, well, show unit test results in the Jenkins dashboard, and introduce a quality gate which says only if your code coverage is at least 70%, then don't fail the build. This is one example of the parameterized trigger build or plugin. So we'll define which should be next in line. It hands over the parameter. And let's also have a look at the next job, which is the integration test job. So there you see, for example, the next one would be the code quality one. So we chain them together. And here you see we actually clone the workspace of our initial job, so we'll get all the files in our workspace. We set the build name again with the provided parameter from the previous build job. We run the integration tests, and here we actually pointed to the separate directory for integration tests. And for JaCoCo, we have a different set of metrics as well. And here again, we do the same thing, except that we can say, simply reuse the build parameters that were set at the beginning. So let's actually have a look at how this plays out in production. Oh, one more look at the deployment one. So here you see we run against a specific environment. It deploys to Cargo with Cargo. And the next one, which should be manually triggered, and that's the option that you use for that, should determine that you basically get this button in that view. And if you go to that view, it shows our chain build pipeline. You can enable auto refresh and actually trigger a new build of our build pipeline, and we'll see. It will show up there, initial job is executed. If you go back to the dashboard here, you'll see it's currently running, so it's updating almost real time. And then it basically executes the next job once it's done. I'm going to take it out here. There you go. So it would go on until it basically hits this stage where we have manual jobs. If something fails, it will stop the pipeline right there. The nice thing is that you can also deploy older versions. So if you have a previous version that you want to deploy, you simply execute that one. So if you want to say, I want to push out the specific feature with that version, and it's provided by this one, you can simply push that one out. So it's still there. You can configure how many build pipeline runs you see here in that dashboard. That's pretty much all I have. I think we're actually early. So I would basically open it up for questions. Yes?
This is probably beyond the scope of the talk, but since we do a little time,
Yeah, sure.
I'm curious. Often when you're deploying a service, you have to do stuff like stop other services, maybe take the node out of the load balancer, on, all this stuff. And you had mentioned Puppet or Chef or CF Engine if you're so inclined. How would one reconcile all of that with what you've shown here? How would you sort of tweak this? Or?
I mean, as far as I know, there's no integrated solution for problems like that at the moment, at least on the Gradle side. Well, you can always call whatever shell scripts or so you have from your Gradle build, so you could actually call it off to it, and then create tasks which depend on each other. Where you can say, well, first shut down the server and make sure that the network configuration is correct, then bring up that server again and do some other configuration. So you could basically call off in your Gradle build script if you wanted to.
Do you have a strategy for managing pipelines across multiple branches? So we have an issue where we have 3 branches and we're doing essentially the same thing, 10 chain jobs, but we don't want to duplicate that to a total of 30.
Yeah, I mean, what I like to do, and you're probably talking about feature branches or something like that, is that the case? Or, so have one integration branch. So you have multiple branches and different developers work on them. At some point of time, you want to integrate that work, and you can potentially point this to an integration branch. We migrate that work, and if you want to bring it into production, you could basically merge that over into that integration branch, and then run the build pipeline on top of it. At my current job, for example, for different branches, we use Git flow as well. But there we do it slightly differently. We only run specific tasks for a developer branch, where we say, whenever you, so we use GitHub, whenever you create a new pull request, it will automatically kick off a Jenkins job, which would compile your code, run your unit tests, do some basic checks, smoke tests, and so on. So we kind of know it's ready to be at least integrated, and then we would integrate it and bring it into the pipeline.
And just along the same lines.
Okay.
We have a few production lines that we're, branches that we're trying to use, and you do the same thing.
Yeah, potentially you might want to, depending on what you're building, you might want to bring it into the binary repository and depend on it, and have multiple build pipelines set up. But it sounds more like you're basically working on the same project, except that you have different branches.
One thing, I think one of my coworkers has developed is a Jenkins DSL. So it doesn't exactly solve the problem, but it allows you to state, the same pipeline once, and then just have variables like branch location, and it'll go and generate the jobs and do the stuff. But you still have that big job list at the end of the day.
It's actually a fairly nice plugin. I haven't used it myself. We basically have a template of Jenkins jobs that we want to run whenever there's a new pull request. But that's actually much nicer, which defines like all the settings in your Jenkins job that you want to run with a DSL. It's kind of nice. Yep.
So we used to have a similar setup of the pipeline, compile and UAT and functional analysis. And one of the challenge for us has been is that your Jenkins is set up for every 1 minute pull from SCN. And when they pull it, we have like 20 CLs coming in one shot, starting one build. And when things fail across the pipeline, it's very hard to point out the CL which actually broke the build. So have you faced anything like that?
I mean, there's another plugin where you can lock a pipeline, where you can say, don't run a new pipeline job or a full pipeline if it's currently running, so at least you can eliminate something of that. I mean, in Jenkins, you can usually see the people that committed the code, so you could potentially find out who did it.
Actually, what happens is that if, so you have your compile and UAT running, one build is running, and there are more check-ins. So you have 4 concurrent builds, and they all combine together when you start the next one. So now you have 15, you have 30 CLs for the next one. that will be even more headache for you.
Yeah, don't have like a immediate good solution for that.
And this where you tag the source control?
I did not talk about it, what you usually would do, and you can run it from your build as well. If you, for example, if at some point of time you say we're ready to release to production, you potentially want to label your source code as well. And I guess that's what you're talking about. I didn't talk about it, but you can just trigger either a shell script, which makes the shell script call, or you could, what I did, because we use Git, you can use a library called JGit. It's a Java-based library which sits on top of Git, basically. And you can run the commands from Java. So that makes it actually fairly easy to do tagging or something else, any kind of operation on your version control system. I believe there's also, there's a Git plugin for Gradle, which hides, again, this complexity of JGit and provides a DSL or custom tasks for you, which allows you to do these kinds of operations. But with that, it's fairly easy to actually hook it up into tasks because it's just called Java code. Anything else?
The release plugin will do some of that as well.
Did you try out the Gradle release plugin?
They, well, one of them, it'll definitely, it supports Git and it's version, I don't know what else, but it'll do source code release stamps when you're doing a release.
Just a Jenkins plugin?
No, it's not. Pardon?
Is that a Jenkins plugin?
No, that's a Gradle plugin.
I tried the Jenkins plugin. Version I was on didn't work across Linux, so I had to do it. But I think they fixed that.
Yeah, I haven't tried out that one. I know it exists, but didn't really tap into it. All right, any more questions? Otherwise, that's it. Thank you.